Formula for circumference. What do you got for me? Boom. 10. What do you got? Pi times d. Got it. Sometimes I may say leave your answer in terms of pi. Sometimes it might be rounded to the nearest tenth or hundredth. All right, so pi d times diameter. All right, next up, length of an arc. That's what we did on Thursday. All right, length of an arc. What's that formula? How to find the length of an arc, how long it is. Oh, 13, hook me up.
Measure of the arc divided by 360 times pi d.
Here we go. Measure of the arc over 360 times your circumference. Last question I have is about this measure of the arc. Where do you get it from? It's a theorem, measure of the arc. And when we say measure, we mean in degrees. In degrees, what is the measure of the arc? How can you find what the measure of an arc is equal to? It's always equal to, part of our theorem, 18.
Measure of angle.
What angle? Get specific. Because it's and I'm only being picky, Claire, because we're going to talk about a bunch of angles in a circle.
Angle like across from arc.
It's got a name. I'm going to pull it out of you. Vertex is the center. Look back if you need to. I'm not even going to spot you any letters because you're better than that. Is it right there in that theorem box, right there on your left-hand side?
What is the measure of its arc?
What's the first part, though?
Oh, central.
There you go, central angle. Okay, measure of an arc. And again, I'm being real picky with Claire because I even think at the end of this week, I introduce a new type of angle in a circle that's not a central angle. Okay, so make sure we know the names of each here. Any questions here? All right, well, I got more. Do you know your vocab now? Hi, this is Circle J. What do you know about J? 14. 1. What do we know about J? If I'm calling this Circle J, what's so great about J? Center. All right? Not halfway, not middle, center. Can you draw radius JR? 19. If I gave you the pen, could you draw radius JR? How about 23? Could we draw it? I'm not asking you to. I'm asking you to help me draw it. Radius JR. Well, you already know where J is. Where's R? Somewhere on the circle. A radius connects the center with a point on the circle. There's radius JR. How about diameter AB? Can you hook me up with diameter AB? 13, diameter AB.
You just extend the line. Just go from arc to the opposite side. No, you have to go through the center.
There you go. That's the key right there. Got to go through the center diameter. Endpoints are on the circle, sure, but it's got to go through the center. And then what about chord XY? Chord XY. What's a chord look like? 8.
It's a line that connects two parts that are on the circle.
There you go. X and Y have to be somewhere on the circle. Can't be the center. Can it go through the center, though? Can a chord go through the center? Is a diameter a chord? That's what I'm asking. Yes, it is. As long as the endpoints are on the darn circle. All right, so there's all the vocab so far. Questions, comments? Any concern before I get into today's topic, which is kind of a little bit different from where we've been? We're all good? We know our vocab. All right, let's move it on then. All right. Something really new to everybody today. Your desk in front of you. If I ask what's the width, you could do it in inches. What other units do you think you could do it in? Centimeters, sure. What else? Feet, millimeters, yeah. You could measure in different units. If I put an angle in front of you, what type of units are you only measuring it in? That's all you've known all your life is degrees. All your life until today. There's a second way to measure angles other than degrees, and it's called, anybody want to pronounce it?
Radians.
Radians, yes. It's called radians. That is a second way to measure an angle. All right, I could do it in degrees, or I could do it in what's called radians. Just to give you guys some kind of picture of how they relate to each other, and please don't write this down because I do not want you to memorize it. 1 radian is about 57.3 degrees. All right, 1 radian is about 57 degrees, give or take. Okay. Why do I need to show this to you? Why can't we just stick in degrees, right? Well, I'm going to show you guys a formula tomorrow that can only be used if your angle is in radians. So today what I'm going to work with you on is, what if I give you a degree measure, can you convert it into a radian measure? And then we'll go the other direction. All right, so that's what a radian is. It's another way to measure an angle other than in degrees. That's why, and do not even go to it. Never go to it this year anyway. Your mode button, you see the word right next to degrees? Radians, because that's the other way to measure an angle. Okay? All right, so how do I convert is the question. How do I convert? On the back of your packet, everybody, you may have this still on you. I don't know, but I assume many of you did it. You got your old reference sheet that I gave you when we did a quadratic formula in the similarity union. You will use this again to convert degrees to radians. How do you convert degrees to radians? You multiply the degrees. Here we go. Multiply degrees by, and this is not something you have to remember because it's on your formula sheet. So once you have this written down, everyone go back to your formula sheet and look in the second column where it says degrees. Everyone see where it says degrees? What's 1 degree equal to in radians? What's the fraction? Pi over 180. And that is what you multiply every degree by. Multiply the degrees by pi over 180. So that's how I turn all these degrees into radians. I multiply it by pi over 180. That formula sheet, you can have it next Tuesday. Okay? You can have it next Tuesday. All right, here we go. Let's do our first one. Take 30 degrees and tell me how many radians it is. So I start with 30, the amount of degrees I give you, and I multiply it by what? Pi over 180, and I'll do it with you on my calculator here. Yep, go ahead, get the calcs out. So I go to my calculator just like you guys are going to yours. I do 30 times, get a fraction template out. Everyone remembers where the pi button was? Right above the caret. Pi over 180. I hit enter. And then I get this decimal. We have been together for a while this year. Odds, I want that whole thing written down on your paper. Pretty slim. You guys know how I hate decimals and long decimals written out, in fact. All right, I can't change it back to a fraction either. I don't want you to round. But it's about what, half a radian? Everyone agree? 30 degrees is about half a radian. So if I don't want the whole decimal written out, how do I want it? In terms of pi. When you write a radian measure for me, I want it in terms of pi, so I don't have to see this whole thing here. So how do I write this in terms of pi? All right, keep the pi in your answer, everyone. Keep the pi in your answer. And then I'd like you to do 30 over 180 in your calculator, because that's what's left over. Once I put the pi in my answer, I go back to my calculator, get my fraction template out, and I do 30 over 180. The calculator will automatically reduce it for me. So 1 over 6. So 30 degrees in radians, and how I want it written is 1 pi over 6 radians. Okay. And what? Hey, just so you guys, just so I confirm it with you guys, just take a look at mine here. Pi over 6. Same thing. Same thing. I just want it clean. All right, I don't want this long, sloppy decimal. I want it clean. So leave your radians in terms of pi for me, please. All right, in terms of pi. All good? Yes, Avery. Hi.
Why isn't it like 1/6 pi?
You could. It's the same thing. Yeah.
Okay.
This right here. Good question. This right here is the same as 1/6 pi. I just don't want the pi in the denominator. That's a totally different. 1 over 6 pi is totally different.
Okay.
But these two right here, pi over 6 and 1/6 pi, exactly the same.
Okay.
Okay? Just don't put the pi in the denominator. One doesn't make you great. Let's keep trucking. 45 degrees. So I multiply the degrees by pi over 180. Leave your radians in terms of pi, please. So 45 over 180. .45 degrees is pi over 1 pi over. Everyone getting 4 radians? And somebody asked a great question, second period. Well, what if I get 2/3? Like everything's been 1/4, 1/6. What if I get 2/3 on my calculator? It would be 2 pi over 3. Okay, 2 pi over 3. Or 2/3 pi. All right, go ahead. See what you can do on 3 and 4. Turn 60 and 90 into radians. Again, I'm doing this with you today because tomorrow I'm going to show you a formula that only works if your angle measures in radians. So we have to convert, be able to convert. Nine. What do you got? 60 degrees is what in radians? Pi over 3 radians, good. And how about 90 degrees? 90 degrees? 7?
Pi over 2 radians.
Pi over 2 or 1/2 radians, yep. Also, I just did this because we're beginning. You don't have to write the word radians at all. If I see pi over 2, I know it's in radians already. Questions? All right, ready to go in the other direction now. Turning a radian into degree. Before we do that, why do I need to have the ability to do that? Remember this formula, length of an arc? The measure of the arc has to be in what? Degrees. Well, what happens if I give you this then? I don't know, the radius of 2 inches. But what if it's pi over 5 radians? Can you just plug in pi over 5? No, you got to turn it into degrees before you use this formula. So that's why you need to know how to convert. All right, you can only use this formula if it's in degrees. If it's in radians, shoot, I got to know how to convert. All right, so let's do that right now. So how do I change radians to degrees? On your formula sheet, take a peek. I'm going to multiply by another fraction now. Look on your reference sheet. Everyone sees where it starts in radians? Everyone see that? starts in radians. Look at the second column, starts in radians. What are you going to multiply by now? Radians to degrees. I multiply by 1. Now it's 180 over pi. 180 over pi. Yep. All right, here we go. So let's convert 7 pi over 6. Everyone notice it's in terms of pi. You're going to see that. 7 pi over 6 radians. Turn it into degrees. All right, you got it. So 7 pi over 6. I multiply my radians by 180 over pi. How many of you guys remember from your multiplying fraction days? Anybody see something in common in the numerator and the denominator? What do they both have in common, eh? So guess what? They can be canceled out. As long as one's on top and one's on the bottom. Canceled out. Hey, is this an equal sign or a multiplication between them? Equal sign or multiplication between them? What am I doing in the two? Setting them equal or multiplying them? I'm multiplying them. So you do numerator times numerator, denominator times denominator. There's none of this cross multiplying business here. All right, there's no cross multiplying. I didn't put an equal sign in between them. So I'm going to do 7 times 180 all over 6 in my calculator. That's what that turns into. There's no cross multiplying here. I'm multiplying, not cross multiplying. 7 times 180 over 6. 7 pi over 6 is the same as, what do we got in degrees? 210 degrees. There it is. And at any time, stop me if something doesn't make sense or you're a little confused. Yeah, go ahead, John.
When you also reduce the other numbers?
Like 180 over 6?
Yeah.
And cross out the 6 and the 180 and put a 30 on top? And then 30 times 7, 210. Yep. Yeah, you can do that. Absolutely. All right, what about 3 pi over 5? All right, go ahead and multiply it by 180 over pi. Again, the pi's do cancel out. Multiply across. Numerator, numerator, denominator, denominator. And how many degrees do you get in 3 pi over 5 radians? 2. 180. How'd you get that? 3 times 180, right? And then you get to divide it by 5.
Yeah. Oh, I did it wrong. I divided by 3 now.
Go, Matt. Go. Yep. Divide it by 5. 108. Good. Good save. 108. And finally 7. 5 pi over 3 in radians, or in degrees, excuse me. And 5 pi over 3, how many degrees? 5?
300.
How many?
300.
300 degrees, yep. Anything you want to ask? Because I'm noticing all my students who usually go ahead of the notes, we're a little stuck on number 8, huh? A little uncomfortable with number 8, are we? Huh? A little uncomfortable. Why are we uncomfortable? Talk to me, kids. Why are we uncomfortable? What's missing there? The pi. Oh, so sad. So sad. Radians don't always have to have pi in it. I got 3 radians. That's it. Not 3 pi radians. That's a totally different number. All right? 3, totally different number than 3 pi. A lot different. Okay, this is 3 radians. So a lot of you guys are getting nervous because there's no pi to cross out. Oh well. What are you still going to multiply it by? It's still a radian. How do you turn it into degree? You still multiply by 180 over pi. Just the only difference, no pi's cancel. So what am I going to have you do? Multiply across 3 times 180, and now divide it by pi, and let's go nearest tenth. Let's go nearest tenth of a degree. You can still do it. Just because there's no pi in there doesn't mean we still don't multiply by 180 over pi. $171.9 degrees. So everyone, all right, you can still do it. All right, the homework is very short, but I want to talk to you about one of the problems. Because you would have thought I was asking my period 2 class to answer a calculus question this morning with that last one. All right, let's talk here. On that last one involves a clock. Can everyone please draw a clock with 12 through 11 on there, please? And I'm just giving you help to understand it. I refuse to tell you how it's done. Refuse. I'm just going to give you help understanding it. All right, the question is, how many degrees and how many radians does the hour hand move from 1 to 9 p.m., correct? Everyone knows what the hour hand is? It's the short one up there, right? It's the short one. Not the minute hand, the hour hand from 1 to 9. All right? Here's what a lot of people think this is like the clock goes around and around and around and around and around till 9 o'clock. That's not what I'm asking for. I'm asking for from 1, and I'm just going to put the hour hand at 9 o'clock here. Now, this is not a minute hand. These are both hour hands at 9 o'clock. I am looking, everybody, for this angle measurement right here. From 1 to 9 o'clock, right there. What is that angle measurement? You cannot get an angle bigger than 360 here, okay? Because that's all the way around plus more. All right, what is that angle measurement there? And I gave you guys a hint that every time the hand moves 1 minute, it's equal to 6 degrees. I remember these are your minutes here in between, right? So every time it moves a tick mark, it moves 6 degrees. All right, so that's as far as I'm going to leave that one. I'll leave the rest up to you and your group if you get that far. All right, go ahead. Let's finish up.